To do that, in Spark 1.6, this is how we do it. We can say ratings df.register temp table, pay attention to capitalization, ratings. Okay, so that means we're going to take the ratings data frame and create a table in Spark SQL called ratings. So now we have a ratings table available to us, and watch this. So I can say %sign SQL, and that means this paragraph is just executing Spark SQL commands. Check this out. Select star from ratings limit 10. Shift enter. Oh, sorry about that. What we have to do, you do not use semicolons, it turns out. It will give you an error if you do. But check that out. We actually got a nice pretty little table of each individual movie ID in the ratings. That just came out of a standard SQL query, select star from ratings limit 10. So our Spark data frame is behaving just like a SQL database at this point. That's kind of awesome. Think about the power of that as well. Let's do something more interesting, shall we? So let's do another SQL command, %SQL, saying that we're going to do a Spark SQL paragraph. This time, let's say select rating, count star as count from ratings group by rating. And if you know SQL, you can probably figure out what that query is going to do. Basically, we're going to create a count of all the rating types. So how many 1-star ratings are there, how many 2 stars, 3 stars, 4 stars, and so forth and so on. Let's kick that off, shift enter. And there's our results, came back pretty quickly. So you can see we have 34,000 some odd 4-star ratings, 21,000 5-star ratings, and so on and so forth. So this is pretty cool, but it gets even cooler. Check this out. I can actually visualize this result any way I want to. Let's actually look at it like a histogram by just hitting that button there. And you can see a visual representation of the distribution of rating types here now. So that's kind of awesome. You can see visually that 4 stars is the most common, 1 star is the least common, and 3 and 5 kind of follow a little bit of a bell curve here. So very powerful stuff. If I was doing a more complex query there, I could visualize it in different ways. I can also do a pie chart. I can do these line charts as well. I can do scatter plots. And again, there are plugins for different visualizers as well. I can actually do arbitrary matplotlib visualizations too, if I want to, if you're familiar with that from the Python world. Or we can just go back to the tabular format here. So just pretty awesome how easy it is to create a visual representation and visualize your data using the Zeppelin notebook. And you can imagine in more complex queries that can really be important in providing you insights into your data. So I think that's kind of awesome. Let's go back to what we promised to do originally and actually tie together our movie titles. So we'll kind of do the same thing we did before for importing our ratings into a data frame, and this time import our movie titles into a data frame as well. So let's just say final case class movie. This will consist of a movie ID as an integer and a title column, which is a string. So again, this is just a way of telling Scala this is the format that we want at the end of the day for our data frame. Then val lines equals sc.text file, capital F, hdfs : // temp / ml-100k / u.item, which is the item database, .map, and each input line will be represented by the x variable and one at a time transformed in the following way. So val fields equals x.split, and this data file is actually pipe delimited, so we have to say pipe thusly, and then we'll return a movie object that consists of the first and second fields of that raw data file. And while we're at it, we'll convert that to a data frame. Again, we need to import SQL context.implicits __ for that to work. And then we can just say, let's scroll down a little bit, val movies data frame equals lines.to data frame. And let's show what we got. Show our work. Shift enter. All right, it worked. So we see the first 20 entries there. Movie ID 1 is Toy Story, 2 is GoldenEye, so on and so forth. So far, so good. Now we can expose that as a table as well. We can say movies df.register temp table titles. Call it titles, why not? And now we can also refer to titles as a SQL database. So let's do a join between our ratings and our titles databases and get some human readable results for our top movies. We've done this same problem about 20 different ways in this course so far, so it's kind of interesting how there's always more than one way to do it, sometimes many more than one way to do it, but I think this way is kind of fun. %SQL, we're going to be issuing Spark SQL commands here again, so let's say select t.title count star, and we'll call that CNT for shorthand, from ratings with an alias of R, and join in the titles table with an alias of T on the movie ID field. Group by title, order by the total count in descending order, and let's just look at the top 20 results. Got all that? All right, a little bit of a fancy SQL query there, but basically we're getting the most rated movies in our database, and we're joining in the movie title information so we can actually see what those movies really are instead of just seeing numbers like 50. Let's kick that off. And it worked. Star Wars #1, Contact, Fargo, Return of the Jedi, so on and so forth. And you can see the final counts in this table as well. And we can also visualize that too. That's also an interesting thing to look at. So let's actually go to the bar chart representation here. And you can see that we actually have an interesting distribution here. If you want to do something even more fun, let's take that limit off and run it again. This way we can visualize the complete results, and you can see there's this interesting exponential curve here that you see all the time in this sort of data. So, if you've ever heard of the concept of the long tail, that's what it's all about. There's a certain number of popular movies or popular items at the head of these distributions all the time, and then a very long tail of movies that have only been seen by a handful of people. But when you take that tail all together, it's just as big as the head. So that's kind of the story of our day, personalized content and connecting people with the right things that are specific to their interests can be a very powerful tool. And that's kind of the power of data science, but I'm going off script a little bit here, aren't I? Anyway, let's recap. That's Apache Zeppelin. Very powerful stuff. I think you've had some fun playing around with this. And just to recap what we've done, we've shown you how to actually do some markdown within a paragraph, and you could intersperse that with all of your different paragraphs here. We've actually run Spark code within a little block of code here within Zeppelin. We've executed shell commands, and we've actually exposed some Spark data frames as SQL tables and used Spark SQL to query those tables and also visualize the results. So that's just a little taste of what Zeppelin can do for you. It's a very powerful tool. I've said that many times, but it really is. All right. Now, if you had any trouble while you were doing this, while you were putting it together, I do have my version of this notebook that I made ahead of time that's all very pretty and whatnot. If you want to download that and take a look, you can just open up a new tab and go to http://media.sundog-soft.com/hadoop/movie-lens.json. And that's a copy of my notebook that I exported and uploaded for you. Once you download that, what you can do is go back to your Zeppelin tab here, click on the Zeppelin homepage here, and you can say Import Note. And click that and select the one that you just downloaded. And you can see that should have created a Movie Lens Analysis with Spark notebook that you can now open from this menu. And by the way, there are other examples here too that you can look at if you want to learn more about Zeppelin. These are also very educational. You can see there's more Spark examples here to look at. There's a Phoenix demo that you might find interesting, and if you're familiar with R, you can play with that too. But let's take a look at the one that I gave you there, Movie Lens Analysis with Spark. And you can see it does the same thing, but I made it pretty. I used more markdown blocks to document what we're doing and made sure that every code block had a title that describes what I'm trying to do with it. So you can get a feel here of how Zeppelin can be a powerful tool for annotating your code and making it easy for other people to understand your analysis and build upon it, which is also very cool. So that's Zeppelin for you. Again, nothing to really clean up here. A few extra files in your temp directory isn't going to hurt anyone. So with that, you can just shut down your virtual machine if you want to, or move on. That's Zeppelin. Hope you had some fun with it. I think it's a pretty awesome tool.